Basic Arithmetic 1, Real Numbers. Real numbers are the numbers that you've been using through primary school and secondary school, but we need to develop a further understanding of the different subsets that are within the real numbers. The first subset of numbers that we need to look at are the integers. Integers are whole numbers. Integers may be positive, negative, or zero. And integers are also known as the counting numbers or cardinal numbers. An example of integers would be 1, 2, 3, some obvious counting numbers. Some negative numbers might be -7, -53. But integers are not just positive and negative numbers, they also include the zero number, which is expressed with a zero. The next set of numbers that we have that are subsets of real numbers are the rational numbers. Rational numbers can be written in the form of a whole number ratio or fraction. So an example of a rational number might be 3/8. 3/8 can be written as a decimal, 0.375. So 0.375 is also a rational number. It can be written as a whole number ratio or fraction. That's a terminating decimal, but we can also have repeating or recurring decimals. So 0.417 is also a rational number, and we'll see how to turn a recurring decimal into a rational number later on. The integers, for instance, an example would be 5, they can also be expressed as a rational number or a fraction, because 5/1 is actually another way of representing the integer 5. So the rational numbers include all the integers. Another subset of the real numbers are the irrational numbers. Irrational numbers are numbers that cannot be written in the form of a whole number ratio or fraction. Perhaps best known among these is the number pi, represented by the Greek letter pi. It's approximately, and a decimal approximation is 3.141592665. That's a decimal approximation. However, the decimal places just keep on going on, and there are no whole numbers that you can express as a ratio or fraction that will give an exact value for pi. A similar number to pi with these properties is the natural number, which is represented by the letter E. Other numbers that are also irrational numbers are square root numbers. The square root of 2 is an irrational number. The square root of 3 is an irrational number. However, if you find the square root of a perfect square, for example, if you find the square root of 4, you'll find that that equals plus or minus 2, and 2 is an integer, and integers are actually rational numbers, so therefore the square root of 4 is not an irrational number. Only those numbers whose square root is not an integer are irrational numbers. This is an overview of the real numbers and the subsets we need to be familiar with.